Mr. Dean here. Let's get to hyperbolas, the last of our conic sections and perhaps the most difficult. All right, we're going to try to go through this video in a somewhat reasonable time, so we're going to have to speed through a little bit of it to get it all in. I'm not a big guy in vocabulary and understanding the every little detail, nitty-gritty about it. On the left-hand side is one definition, on the right-hand side is another. We don't often use that definition, but it's kind of a neat definition to kind of look at and understand where hyperbolas come from. Now, hyperbolas in our lives. So when are we ever going to use these? Well, if you're a big fan of the environment, you look at nuclear power and you say, well, look at all that, the hyperbola of a nuclear power site. If you're a fan of it and you like nuclear power, then this is a better picture. You got trees, you got blue sky, etc. If you're a fan of architecture, just look at the architectural part of it. If you're a fan of physics, you start thinking about how a softball or even a baseball might curve, or a rise ball based on the stitches being in a hyperbolic pattern around there. And if you have no interest in any of these, perhaps you could study these curves and be more interested in the math behind it. So there's all sorts of websites to tell you all about the details of hyperbolas, but I think they overdo it. I think it's not this crazy. It makes it look really tough. One thing that is kind of interesting is the fact that asymptotes are back. All right, so there are asymptotes, and if you kind of just twist this graph and think about graphing 1 over x, when we did rational functions, the graph of 1 over x was a hyperbola. We've already seen these, and they had asymptotes back then too. So a couple more pictures, but we don't need to necessarily, you don't need to put these in your notes even. Just the idea that the transverse axis is that blue axis that either goes up or down or left and right. Basically, it goes right through the focus and the vertex. The conjugate axis is the other axis, and I've never really used that phrase before, so don't get yourself all worried about it. Let's go right to standard form. Now, you are going to use this. This is what we want our equation to look like. If it's not like this, then we're in some kind of trouble, either the top one or the bottom one. And take a look. That minus sign is in green because to emphasize the fact that it's important. If it was a plus sign, we'd be dealing with an ellipse. So if it was a plus, our shape would look like this. And if it's a minus sign, the shape actually looks like that. So pretty neat. Just that one little difference changes it from an ellipse to an hyperbola. Won't get too bent up about the details between the differences in the top and bottom. It's all about these two terms, A and B, kind of switching around, but we'll deal with that as necessary. Oops. So let's talk about how A and B are related in a hyperbola. And I'm going to keep it short and sweet. Because the focuses, the foci of the hyperbola are sort of on the outside of the hyperbola, further away than the vertices, we use this formula, c squared equals a squared plus b squared. Slightly different than the formulas we use for some of the others. So of course that means, you know, that you can take the square root. That's a square root symbol if you can see it. So c is a square root of those, that sum. And the asymptotes of a parabola, well, sort of important. I think this is actually starting to get to the point where we're starting to make it more confusing than it need be, but you can always go back if you're having some real difficulty in finding the asymptotes, but there are some shortcuts. We're going to try out those right now. All right, so sketch 4x squared minus y squared equals 16. We want this equation to look like the standard form, so we're going to divide by 16 so that we get a 1 on the right-hand side. And I've done that. I've simplified fractions. And right now, you have a pretty close to an idea of what's going on. I'm going to find out that in the x direction from center, I'm going to go 2 spots in either direction. 2 spots because that's 2 squared. And in the y direction, I'm going to move up and down 4 spots. And notice that I kind of have this idea of a rectangle. I draw in that rectangle. Oops, I drew it too far. Try that again. That rectangle should go right through 2. So let me try that again. There we go, through 2. All right, good enough. And I know the center is right in the middle. All right. So I know that my asymptotes, believe it or not, are right in that direction, and my graph then is going to go right along that pink asymptote on both sides and it's going to follow right through the vertex, right? I may move that one in just a tad. That should go right through the vertex there. So, yeah, and that's it. My black line is my graph. I know it is pointing to the left and to the right because I have a minus y squared, right? So because the x term is positive, the transverse axis, to use that fancy term, there it is there, is horizontal. But the only part of this whole fancy graph that's really part of the graph is the black part. Everything else is just there to make those graph correct. Now, if you want to find the asymptote, well, you can find the calculations of that asymptote. It's rise and run is 4 over 2. All right, see my slope triangle there? And it's going through 0. So the two asymptotes, y equals 2x, and of course the negative one going down the other way is y equals negative 2x. That problem's not too bad. Let's try a harder one. And now let's make sure that we find the vertices, the foci, and the asymptotes. So the good news is my graph, my equation actually is in pretty good shape just the way it is, all right? Recall that a is equal to the square root of 64 and b is the square root of 25. And we can then find, well, let's find the center here. Let's do that. So we're at, x, just be careful. It's in the different order than we used to. 3, 2 is the center. So the center is 3, 2. And my vertices then are going to go up and down 8 because it's larger in this y direction, right? So I'm going to go up 8 from there to 10, and down 8 to negative 6, I believe. I got this right. Yeah, just double checking. So that looks good. And I now kind of know a little bit about the graph. I know that those are the vertices. So I got A, I got B. Let's find C. And C turns out to be the square root of 89, which is what? A little less than, somewhere between 9 and 10. All right? So that C number tells me how far from my center, this is my center, of course, how far up and down from my center that the foci are. And the foci are along my axis of 3, 2. That's my center. But I want to add and subtract that number there. So I'm going to add and subtract around, what we say, somewhere between 9 and 10. So I don't know, we'll go up 9 from 2, so it goes to 11. So foci somewhere in there. And go down that far, foci somewhere there. All right. And I want to also use this number 5. That's going to tell me to go to the right 5 from my center and to the left 5 from my center. And this is my rectangle that I draw very carefully there. All right, looks good. And my asymptotes are going to go from the center to each corner. Sketch those in there. My scale on this graph is weird. It might not match yours. I'm going by 2s, and my y is a little stretched out. And so, I used that formula. I went back to the asymptote formula to tell me that it was the a over b, and this x minus 3 goes in there. Not a big deal. But what is the big deal here is that my vertices were right there and right there. Can't forget about those. And I'm going to draw my graph so it goes along the asymptotes. All right. My focus, remember my foci, both of them, are over there and over there. I got my center. So everything looks good. I think I've identified all those things. All right. Let's take another look at one more. So we'll write the equation here of the hyperbola with foci at 0, 7. All right. So I labeled that, and 0, negative 7. So these are the foci. That's one, that's another one. So I know that the entire distance is, the distance from, let's say, the entire distance is 14, and the center has got to be 0, 0. So I know because the foci are kind of balanced, in between the two foci will be my center. So my center is at 0, 0. And it says the transverse axis is 12. Well, if it's centered at 0, 0, the transverse axis has got to be at 6. All right? So I'll do some more work here. Let's find what the B is. And the B is about 3.6. Okay. So that distance between my label that with a V and that with a V. That was 12, the distance between those two V's. And I just want to know how wide to make this thing, and it's not a really comfortable number, but we'll go over 3.6. So right about where that was, and that, I already have that labeled out. Now I'm going to put my dashed line, how about that? And now I'm going to put my asymptotes in there, connecting the center to the corners. And then my graph is going to follow along those asymptotes, and it's not going to pass into that box. All right, so remember that graph doesn't go into the box at all. It stays out of that rectangle and goes along eventually to the asymptotes on either side. Now, how did I know it was sort of up and down instead of left and right? Well, it was because, for a couple of reasons, our foci was all in order, and it was along the y-axis, so it had to be going in that direction. All right, so my transverse will be right through the y-axis. All right, so we went through pretty quick. I know there's a lot of detail we left out, but you did a great job, and we will see you in class.